Guys, welcome in today's session. I am Professor Fayaz Kawadi from Department of Mechanical Engineering. In today's session, we are going to study the universal dividing head, construction and working from machine tool and their application, which is the part of universal dividing head is the part of milling machine from manufacturing process to subject. So let us start. Universal dividing head, you can see the three-dimensional image, three-dimensional figure of constructional detail of this dividing head, which is not the integral part of milling machine. It is an attachment for indexing process in milling operation. So what is the indexing process? So indexing is the process of evenly dividing the circumference. Indexing is the process of evenly dividing the circumference of a circular workpiece into equally spaced division. I repeat again, indexing is the process of evenly dividing the circumference. Remember this most important point, evenly dividing the circumference of the circular workpiece into equally spaced division. It is used in cutting gear teeth, cutting splines, milling grooves in reamers and tabs, and spacing hole on a circle. So while cutting the teeth on a blank disc, this is a blank disc. Blank disc is the disc before cutting the teeth. Okay, on that blank disc, you have to cut the number of teeth, and that teeth are evenly spaced around the periphery of that blank disc. Okay, so if you want to cut the teeth on the blank disc, you have to rotate that blank disc evenly after cutting the tooth one by one. If you remove the material from the blank disc, after that you have to rotate that blank disc through a specified angle, through a particular angle to cut the further next adjacent tooth, and one by one you will go on cutting the tooth on the blank disc, and you will prepare or you will manufacture the gear. Okay, in this condition you have to rotate the blank disc through a particular degree every time. So that rotation of that blank disc is called as indexing. That indexing may be intermittent, or that rotation of the workpiece may be continuous. Here you can see the drill, and here you can see as the image of a reamer. Okay, in case of this is called as flutes, which is cut on the blank drill. That flutes is the part of the drill through which the chip is removed from the workpiece. Okay, that flutes is required to cut on the blank drill, and in that case these helix are cut on the drill, and these helix are cut due to the continuous rotation of the drill, continuous rotation of blank drill. So this continuous rotation through a particular degree, through a particular continuous rotation here on for preparing the fluids on the blank drill, that rotation is called as an indexing. Here this is the image of a reamer. One flute is cut on that reamer. Okay, and after cutting one flute, that blank reamer is required to rotate through a particular degree, and second flute will cut on the reamer. In this way, number of flutes are cut on the reamer one by one, and this rotation of this blank reamer is called as a indexing. So is that clear? What is indexing? Indexing is a rotation of blank disc or a rotation of blank drill or reamer through a particular angle, and this is evenly divided on the circumference of that circular workpiece. That process is called as a indexing. And the example of the indexing is cutting of teeth on the gear, cutting of fluids on the drill, or cutting of fluids on a reamer. So whenever you require to rotate the workpiece through a particular angle, that operation is carried out through the indexing, or this operation is called as an indexing process. Is that clear? Okay. Now that operation is carried out, the universal divide, the component which is known, the attachment which is known as a universal dividing head, or simple it is called as a dividing head. So you can see the image on the milling machine, or attachment on the milling machine, which is called as a dividing head. Here, this is a dividing head which you can see, and the workpiece, a reamer or blank disc on which you have to cut the gear tooth, okay, or drill is mounted in these centers. Okay, this is, or you can see at the center of headstock, or this is, and this is called as the center of tailstock. So this part is called as a tailstock in this attachment. Okay, and this is called as a, again, a center of this dividing head. So in between these two center workpiece is held, which is to be rotated, which is to be indexed. Okay, and this is a dividing head. This is called as a indexing plate. This is called as a indexing plate. This you can see, or this is visible, okay, in that attachment. This is visible in this attachment. So this is the constructional detail of that indexing plate. The indexing plate is a equispaced holes around the various circles. Okay, number of holes are cut or drilled on that indexing plate. So this plate is designed or patented by Brown and Sharp company. Okay, Brown and Sharp company. So these holes are equispaced. Whole circle also is equispaced. Holes on this circle is equispaced drill, and this number of circles are also equispaced. Okay, and this plate is designed by the company Brown and Sharp, and also patented by this company. So number of holes which are cut on is specified numbers. Okay, the first circle, in the first circle, the 15 holes are drilled. Okay, in second circle, 16 holes are drilled, equispaced holes. In third circle, 17 holes are drilled, and these holes are equispaced. So in first plate, there are three plates. In first plate, the holes which are drilled on the index plate is 15, 16, 17, 18, 19, and last one is a 20. So 15 holes circle, 16 hole circle, 17 hole circle, 18 hole circle, 19 hole circle, and 20 hole circle. This is called as the first index plate in that, which is designed by Brown and Sharp company. Second plate is 21 hole circle, 23, 27, 29, 31, and 33. Last one is a 33 equispaced hole is drilled on the outer periphery of this second plate. Third plate is 37 hole circle, 39 hole circle. This is, instead of 15, this is 37 hole circle. Next is a 39 hole circle. Next 41, 43, 47, and 49. These numbers you have to remember, which is drilled on the first plate, second plate and third plate if not given in the examination while solving the numericals. Okay, at a time only one plate is mounted on the dividing head. At a time, either plate number one, first plate will mount, depending upon the number of teeth which you have to cut on the blank disk according to your calculations. Okay, according to your calculation of how much teeth is to be cut on the blank disk, on that number of teeth. Okay, on this number you will choose the, either you have to use first plate, or you have to mount second plate, or you have to mount third plate in this universal dividing head attachment. Okay, this is first plate. So either this first plate or second plate or third plate is mounted in this universal dividing head attachment. Okay, so this is visible on the attachment. This is visible on the attachment. Okay, this is called as an index plate. Second thing, this is called as a crank, which is rotated on this index plate. This index plate is fixed on this attachment. Once you have fixed that, only in that case this crank is rotated. Why it is called as a crank? Because this crank is rotated through 360 degree. That's why it is called as a crank. Whichever part is rotated through 360, that part is called as a crank. Okay, this is called as a crank, and this called as a plunger. This called as a plunger. This plunger, you on the opposite side of the plunger is small pin, and that pin is inserted into that holes on the index plate. Okay, as per your calculation. So once you fix that pin into that hole, and you will cut the teeth on the blank disc, and as per your calculation you remove that plunger from this hole, and you will rotate that crank as per your calculations, and for cutting the next tooth, you will rotate that plunger, you will rotate that crank and insert that plunger for next cutting of teeth on the workpiece. You will insert on next hole as per your calculation. So this index plate, this crank, and this plunger of this plunger pin along with this plunger pin is visible in this dividing head attachment. Okay, and whatever construction in that, now we are going to see this plunger. You can see here this index plate, this plunger, this crank. You can see here this crank and this plunger. Okay, this plunger you can see in this attachment. You can see here this main index plate, this main index plate, this is the crank. Okay, and this is plunger along with this pin. Okay, along with this pin you can see in that attachment. Okay, this is visible in that attachment, this main index plate, this crank which is rotated. Okay, here this index plate, this white color plunger, and this crank, and this plunger you can see in this top view. This is the constructional detail which is shown in top view, and this figure you have to clearly understand, and the name of different parts in constructional detail may be asked in the examination and in multiple choice also. Okay, so this is rotated. So when this crank will rotate, this complete valve shaft will rotate. Okay, and this main index plate is fixed with help of this lock pin in body of that dividing head. Okay, see here this index plate is fixed. This is not rotating. Once you set the plate, this is fixed with help of the pin, lock pin. Okay, this you can't see in this image, so I am showing here in top view. This main index plate is fixed, once fixed in this divided head with help of this lock pin. Okay, and this crank is rotating. Okay, this crank is rotating. So what constructional detail is inside that dividing head which is not visible, that we are going to see now. Okay, in that this complete is enclosed. This you cannot see. This is invisible in that construction, in that attachment. So this crank is connected with this worm shaft which is enclosed in that you can say canopy or attachment. Okay, this worm shaft, okay, this crank, when this crank will rotate, this worm shaft will rotate. Okay, and these are the bevel gear which is not continuously used in gear cutting operation. In helical gear, in cutting the helical fluids on the drill, at that time this attachment is used. Okay, so there is a relative motion in worm shaft and this bevel gear attachment. Okay, so when this shaft will rotate, worm shaft, it is not necessary this bevel gear will rotate. There is relative motion in between this bevel gear B and this shaft. Okay. So when this crank will rotate, I am showing the working also along with the constructional detail. When this crank will rotate by hand, with as per your calculation, so this is connected with this worm shaft. This worm shaft will rotate, and on the other end of this worm shaft, worm is mounted. So worm and worm assembly is enclosed in this dividing head, which is not visible here. Okay, that is internal constructional detail which is I am discussing with you. Okay, this is other end of that worm shaft. Worm is mounted, and worm when this worm shaft will rotate, so worm will rotate, and worm is attached with this worm wheel. Worm is attached with this worm wheel, and this worm wheel is having 40 teeth on this worm wheel. This is standard. Okay, here you can see this is worm wheel. Okay, this is worm shaft, and this will be the worm, single threaded worm. Okay, there are again different type of single thread and multiple thread. Okay, so this is single threaded worm, and this worm is attached with this worm wheel which is having 40 teeth, and this is standard. Okay, only 40 teeth is cut on that worm wheel. So this when you rotate the crank, okay, when this you remove the pin from this hole, okay, and rotate the crank as per your calculation. Okay, and this calculation is depend on how much teeth you have to cut on blank disc. Okay, so this you remove the pin here, and after removing the pin, this is spring loaded pin. Okay, so you will pull that pin, and after pulling, this will remove from the hole of that indexing plate, and you will start rotating the crank. Okay, when you start rotating the crank, at the same time this worm shaft will rotate because it is mounted on that worm shaft. Okay, when worm shaft is rotated, this worm will rotate, and this worm is attached with this worm wheel having 40 number of teeth. Okay, that means when you will rotate through one revolution of this crank, one revolution of this crank, at that time this will rotate one revolution of the. So if you rotate one revolution of this worm, at that time this will rotate 1 by 40 revolution of the worm wheel. Okay, that means in other words I can say that if you have to rotate one revolution of this worm, you have to rotate 40 revolution of this worm. Okay, is that clear? Is that clear? When you will rotate the crank through one revolution of crank, that means one revolution of worm wheel, sorry, worm. Okay, so when you rotate worm through one revolution, this will rotate through one tooth of the worm wheel. That means 140, 1 divided by 40 revolution of this worm wheel. That you have to clearly understand. Okay, now come to the next point. Okay, this when this worm wheel will rotate, a worm wheel is mounted on that spindle. Okay, on that spindle, on that spindle. So when worm wheel will rotate, spindle will rotate, and on the other end center is there. So along with this spindle, this center will rotate, and the workpiece is, this is the blank disc on which you have to cut the teeth. Okay, you have to cut the teeth. So that you have to rotate through a particular degree. So when this center will rotate, this spindle along with this carrier will rotate, and this, when this spindle will rotate on which the blank disc is mounted, this will rotate to particular degree. So in this way, motion is transmitted as per your indexing calculation to the workpiece, from the crank to the workpiece on which you have to cut the tooth. Okay, is that clear? This crank, as per your calculation, you will rotate by removing this pin, which is a spring loaded pin. You will pull that plunger. At that time, this pin will remove from this indexing plate, and as per your calculation, you start rotating that crank. When this crank will rotate, this worm shaft will rotate. On the other end, this worm is mounted. On the other end of worm shaft, worm is mounted. Worm is meshed with the worm wheel. So this motion is transmitted from worm to worm wheel. Worm wheel is mounted on this spindle. So this spindle will rotate. When the spindle will rotate, center is mounted here. You can see here this center. Okay, when this spindle will rotate, this center will rotate, and with the center will rotate, the workpiece which is mounted on that spindle, that will again rotate. So in this way, rotate, and you will get the indexing, and you will get the particular rotation as per your calculation to cut the teeth on blank disc. In this way, this is the constructional detail and working of the indexing mechanism. So what is the function of this bevel gear? This is used for different operation. If fluids are cut, at that time you have to rotate that workpiece continuously with standard RPM, so that at that time this will be in operation. This bevel gear A and B. When this bevel gear will rotate, this motion is transmitted to bevel gear driven shaft, and again this will transmit to bevel gear driver, and through this motion is transmitted to the workpiece. Okay, is that clear? So I repeat again, it is a work holding device like rotary table. The workpiece may be held and rotated between centers. The rotation of workpiece, the rotation of this is workpiece blank on which you have to cut the teeth. This rotation of workpiece is provided through a worm and worm wheel, with a gear ratio of 40:1. Why 40:1? Because 40 teeth is cut on the worm wheel. And this is standard. Okay, this is standard. So one rotation of index crank. This is index crank. Okay, one rotation of this crank, this means one rotation of this worm, because this is connected through to each other with help of this shaft. Okay, so one rotation of this index crank thus rotates the workpiece through one tooth of workpiece or worm wheel. So one tooth of workpiece, how this is connected to this worm wheel. So whatever rotation you are getting here worm wheel, the same rotation you will get here on blank disc. That's why I written here workpiece through one tooth of worm wheel, or 1/40th of its rotation. 1/40th of worm's rotation. 1/40th of worm wheel rotation. Okay. In this way, this dividing head is working for cutting the tip on the blank disc in case of gear cutting operation in milling machine. So students, at the end of this session, you can understood the universal dividing head milling attachment, that is called as a milling attachment for indexing the blank gear in teeth cutting operation of gear. So